During this video presentation, I'll be going through quantitative data analysis techniques. So just to kind of start off and set the tone of this video presentation, I'll just give a quick overview of quantitative data analysis. So quantitative data analysis is all about the different ways of presenting, organizing and analyzing data that is collected from testing or a quantitative study like a questionnaire. It's crucial that it's done well and professionally in order that you produce reliable and trustworthy statistical analysis to be able to ultimately reject or accept the null hypothesis of a study. So I'm just going to start off by talking about the different ways of organizing data. So within quantitative data analysis, there are 4 ways of organizing the data collected. Adams et al. States that each one of these ways of collecting data provides a good starting point to the appropriate research project. The first method is the range. So the range of a set of data is defined as the distance in the numerical value from the highest to the lowest value collected. In sport and exercise science research, it is hard to understand why the range of a set of data is calculated. However, my understanding is that it gives a researcher an indication as to how extended the results are. So what I mean by this is that if a set of data has a high range, then it could be inferred that there is a wide spread of data with low and high values across the data set. However, the range can become misleading if outliers are included in the calculation. So for example, if most of the values of some raw data are kind of around 5 to 20, but one value is 126, for example, then this will produce a misleading range value when the range is calculated. Moving on, as you can see at the bottom of the screen, I've calculated the range for all the gymnast data of 14 gymnasts and put them in a table. And then above that, I've clearly broken down the process of calculating the range. So for specifically the static sprint scores of the gymnasts, I've identified the highest value, which is 7.62, obviously seconds, and then the lowest, which is 1.95 seconds. I then proceed to minus 1.95 off the highest value, which is 7.26, leaving me with the range value, which is 5.31. Secondly then, rank order distribution very simply means that you place your data in an ordered list from the lowest data value to the highest in just one single column. A huge part of rank order distribution is that you include all of the scores and that they have been put in the correct order, otherwise it completely messes up the whole idea around the rank order distribution. As you can see on the screen, I've organized the chest throw data of 14 gymnasts into a rank order distribution. The only real explanation for organizing your data into rank order is that it puts all of the scores in a clear format in order of rank, which could be useful for a researcher if they are comparing how scores decrease or comparing the different ranks between certain participants. Thirdly then, simple frequency is an alternative to rank order distribution. So for simple frequency distribution, it will require the use of a table with 2 columns. One column will be for the raw data scores that will be put in order, and then the second column is for frequency scores. To explain it better, I have an example of simple frequency distribution for bicep skin fold calipers of 14 gymnasts. I have noted down the different skin fold caliper scores in the raw data column, and then in the frequency column I've written down the number of times that the measurement was taken. For example, 5mm was measured on 4 different gymnasts. In my opinion, simple frequency distribution helps to break down the data, and it leaves it in a simple, easy to understand format. It is particularly useful if you have a large raw data collection. Finally then, the final technique for organising data is grouped frequency distribution. The process of this involves a statistical method to organise and simplify a large set of data into a smaller group. Similar to simple frequency distribution, the grouped frequency tables has two columns, except the first column is for group scores instead of individual scores. As you can see from my example of grouping the sit and reach scores of 14 gymnasts, I've created groups from a range of the data spread. For example, as you can see on the screen, I have made 6 groups of data ranging between 20 to 25, 26 to 30, 31 to 35, 36 to 40, 41 to 45, and finally 46 to 56. In the frequency column of the table, I have simply added the number of the values that lay in each group of scores. So as an example, there were 3 sit and reach scores that lie between 20 to 25 centimeters. To conclude, group frequency distribution is a bit more advanced in terms of putting it together, but it can be really helpful when you have a lot of data and you want to display it in a much simpler form. So now we're going to move on to ways of presenting data. So firstly, we have a raw data table. There's not much that can be said about this, apart from people often forget about being able to include the raw data table as a way of presenting the data. The raw data table is simply the table that you would have used to note down all the different scores for your participants. So as you can see here, I've got the raw data table for all 14 of the gymnasts. It has their sex, whether they're male or female. I've just included 2 columns of static sprint scores in seconds and standing vertical jump scores in centimeters. So yeah, this is just an example of raw data table from the study of the 14 gymnasts. But it can be helpful for simply picking out individual scores or analysing the whole set of scores without making any changes to the data table in any way. So secondly then, scatter graphs are an example of presenting data. So scatter graphs are used to present a relationship between 2 variables or aspects for a set of paired data. The pattern of the scatter graph is ultimately what describes, I guess you call it, the relationship between the 2 variables. So as you can see on my screen, I've got an example of a scatter graph which compares the relationship between static start and flying start in seconds of the 14 gymnasts. And as you can see, this line which shows a positive correlation, which means as the flying start scores increases, so do the static start in seconds for all the participants. As you can see though, it's important to mention that there's an outlier on this example of the scatter graph. Usually researchers ignore the outlier because it's a bit of data that isn't relevant to the rest of the data set. Thirdly then, we've got a line graph. So a line graph, which can also be known as a line chart, is a type of chart best used to visualize the value of something over time. So the line graph consists of a horizontal x-axis and a vertical y-axis. Most line graphs only deal with positive number values, so these axes typically intersect near the bottom of the y-axis and the left end of the x-axis. The point at which the axes intersect is always 0, 0, and it's important that each axis is labelled with a data type, so people viewing it understand what the line graph data is showing. Data points are plotted and are connected by a line in a dot-to-dot fashion. An example of a line graph comparing systolic and diastolic pressure of 14 gymnasts is presented on my screen now. Obviously you can see it's labelled, it's got a title, and I've also included a table of all the different results, well, the systolic and diastolic scores of all 14 participants on the bottom as well. The bar charts. Bar charts are a type of graph or chart that are used to display and compare the number, frequency, or other measures like the mean for different discrete categories of data. They are one of the most commonly used types of graph because they are simple to create and also very easy to interpret. They also a flexible chart type, and there are several variations of the standard bar chart, including horizontal bar charts, groups or component charts, and stacked bar charts. The one I have on my screen is just a simple common bar chart. So my example of a bar chart presented on the screen shows the chest throw scores of 14 gymnasts. As you can see, it is really easy on the eye, and it's easy to interpret what the graph is saying or representing based on the data I've added into it. Bar charts are one of the first charts that are usually introduced to kids, very simply due to their simplicity and the fact that they're easy to read. So box and whisper graph. So in descriptive statistics, a box plot is a method for graphically depicting groups of numerical data through their quartiles. Box plots may also have lines extending vertically from the boxes, which is what creates the box and whisker graph, indicating variability outside the upper and lower quartiles. Outliers may be plotted as individual points on the graph. Moreover, the spacing between the different parts of the box indicate the degree of dispersion, otherwise known as the spread, and skewness in data. And this is also where outliers would show if there are any at all. So as you can see on my screen, I have a box and whisker graph to show the difference between thigh and upper arm girth for all 14 participants, gymnasts. As you can see, I've got both axes labelled, and I've included a clear title so that people viewing it can understand what the box and whisker graph is presenting. So a histogram is a special form of a bar chart where the data represents continuous rather than discrete categories, where it shows the frequency or how often each different value in a set of data occurs, where the data is often grouped to reduce the number of data points, and is the most commonly used graph to show frequency distribution. So again, as you can see presented on my screen, I have a histogram representing height of participants, the 14 participants, who are obviously all the gymnasts. So finally then, we have normal distribution. So a normal distribution graph will have this bell shape that surrounds what could be a histogram, potentially. If a data has a normal distribution, it means that most of the data within a data set are close to the average, while a few will be at one extreme or the other. A normal distribution graph has one single peak. It is bell-shaped. The mean lies at the center of the distribution, which creates a symmetrical distribution, and which creates a symmetrical distribution around the mean. And finally, the shape of distribution is determined by the mean and standard deviation. The mean of a normal distribution determines the height of a bell curve, and the standard deviation of a normal distribution determines the width or spread of the bell curve. So not all normal distribution graphs will be perfectly bell-shaped, like the one presented on my screen. They can be flat or steeper depending on the mean and standard deviation. There are three types of this distribution curve, these being a normal distribution, which is shown on the screen, and also a positively and negatively skewed curve. A positively skewed curve is when the shape of distribution is asymmetrical, and the longer tail of the curve points towards the positive higher end of the scale. Also, all of the scores will be bunched to the left of the center, On the other hand, negatively skewed curves have the long tail